Good morning, and welcome to another in the series of the Center for Carbon Management and Energy webinars here at the University of Houston. For those of you that joined us in April and May for our series at that time, we welcome you back. For those that have not joined previously, we welcome you, and we intend to move from this webinar to several others through the rest of the summer. But today our focus is on carbon capture, utilization and storage and enhanced oil recovery. But particular of interest today is you'll hear about project work that we're doing in India. And I think it's not lost on anybody how important from a global perspective it is that CCUS technology be migrated globally. And that'll be our theme today. My name's Chuck McConnell. I'm the director for the Center of the Carbon Management and Energy program that we have here at the university. And of course, many of you that know us already know that we're committed to the three elements of the energy trilemma, that we have abundant and available, reliable energy, that it be made available and affordable in a cost-competitive manner to the marketplace, and all the while being driven by the importance of the energy transition and sustainability. Carbon management being at the center of all that. And so we're delighted to continue our efforts throughout the year. It's been difficult for all of us, but we have continued to move it forward, and we're really delighted that you've joined us today for our webinar. I did want to introduce two classes that we've developed. These are online programs with a process around them called micro-credentialing. And what we're doing is making these courses available to the general public from the University of Houston Energy programs. It allows people to take these classes online. There will be 4-week programs. One of the programs, called Sustainable Energy Development, will begin on July the 28th. We also have a course on upstream energy data analytics, which will begin on the 20th of July. These programs will be held twice a week, and for a period of a month. You'll take an online program for those evenings, a couple hours each night, and in 4 weeks have a credentialed recognition by the University of Houston Energy program that you have achieved a level of understanding, and it will be something that you can put on your resume, whether that's in LinkedIn or any other of the programs that provide that kind of credentialing. And we're looking forward to this new way of getting to the marketplace for yourself, but perhaps even for those in your organizations that are new to the energy market, that can become educated in a manner here unlike typical educational programs. And we're excited about this. We think this is going to give us a much bigger reach into a marketplace that's hungry for this kind of information. So please visit the site at the bottom of this chart to find out more about this. You can ask the questions, you can register and learn more about it and get prepared to join us online for these two new programs that we'll be launching in July. We also have some upcoming webinars, one in July and one in August. We don't have firm dates yet, and so we'll ask you to continue to stay close to the webpage for the Center of Energy and Carbon Management. We're uniquely positioned for the July program to have two members of the federal IRS team actually being our featured presenters. There's a lot of work that's gone on, recent developments and market impacts from the IRS comments that have been added to the 45Q. And we're excited to have these members of the IRS participate in our webinar. They'll probably remind you to get your taxes done by the 15th of July, but more importantly, to focus on the 45Q efforts that are ongoing. And we're especially thankful to have the coordination of one of our center participants and sponsors, Hunton Andrews and Kurth, also coordinating this work for us and with the IRS. Should be a good one. In August, we're going to further discuss CCUS, but with a specific focus on the Permian. And the work that we've been doing of late, especially, is looking at the Permian not so much just as a place where enhanced oil recovery can occur, but looking at the geological regime and repository there as an asset for the efforts in terms of CO2 storage, but certainly also for enhanced oil recovery. But we believe that it's a unique place in the world that through our efforts and the efforts of those that are in the marketplace, we'll be looking at that. We expect to have Steve Melzer, one of the renowned contributors in that region in the Permian, as our featured speaker. And of course, our folks in Petroleum Engineering will also be involved in that conversation as well. So please don't miss either of these two upcoming events. You can learn more about the webinars that are upcoming, but I'll also remind you that if you go to our site, you can see the archived webinars from the months of April and May. We had a series of 5 of these webinars that occurred that were very well attended, typically averaging over 200 people per event. And these are archived so that if you've missed anything, or if you'd like to share them with any of the people in your own organizations, would encourage you to go to that webpage and be able to access that. As you listen to today's presentation, please remember that the platform here provides a chat function. Ask your questions. We'll bring those in as the conversation and presentation is occurring. I'll do my best to group them so that we can cover as much of a landscape as possible, but please use that chat function while you're listening to the presentation. And in fact, you'll be able to continue to use that function throughout the Q&A process. So today we're delighted to have one of our distinguished professors from the University of Houston, Dr. Ganesh Thakur. Ganesh has been involved in the marketplace in the industry for well over 40 years, very well known, has done a lot of work himself out in the Permian, but also will be sharing today with you a really, really interesting set of activities that's been going on in India over the past several years for the University of Houston. And of course, the global migration of this technology, fundamental to addressing climate change issues, as well as moving the enhanced oil recovery know-how and knowledge and technology to the marketplace. So I'll turn the stage over to Dr. Thakur, and please use your chat function, and we'll look forward to the Q&A at the conclusion of the presentation.
Good morning, everyone. It's a great pleasure for me to be here and talk about a subject which is very close to my heart, the CCUS, carbon capture and carbon dioxide, EOR, and storage. So this morning, I will be discussing various aspects of this project, and the outline of my talk is given here. First, we talk briefly about the greenhouse gas challenges. Then we'll talk about the anthropogenic CO2, CCUS, and we will talk about a few projects around the world and several EOR projects with the US examples. Then we will be briefly discussing the CCUS research that we have going on in India at this point in time, the Oil India project, and then finally we will summarize the presentation. As we all know, petroleum and natural gas still plays a very important role in the primary energy source. And coal has been declining quite rapidly. And thankfully, we have renewables increasing in consumption and filling the needs for energy as a source around the world in different forms around different countries. So we look at the motivation for the CCUS is that increasing of the emissions in various countries around the world. As you can see, the emissions increase in countries like China and India. They are happening at a very, very rapid rate. As we see, 2 to 3% increase per year, whereas the emissions is decreasing in some countries. The US and the EU is still at a significantly high level. And also you can see in other countries, increase of emissions is also pretty significant. And that's the motivation for this talk about capturing the CO2 from the production of in the energy industry, transportation, refining and petrochemical production, and also from the end use, and capturing that CO2 in some forms and injecting into the formation. There are several ways to dispose the carbon in the underground formations. It could be direct geological storage, injection of captured CO2 into deep saline aquifers, injection into depleted oil and gas reservoirs, and CO2 utilization, for example, enhanced oil recovery, which we will be focusing on quite a bit this morning, and also potential for injecting CO2 into the tight oil reservoirs, into the residual oil zones and transition oil zones, and other possible industrial usage. As you can see here by the starred items for those areas, petroleum engineering and geoscience core skills are going to be highly in demand. So there are quite a bit of potential for the petroleum engineers and geoscientists to get involved in these projects. And also it opens up opportunities for our students in the future. Several anthropogenic CO2 there are several projects which are shown here. Some of them are EOR projects, and some of them are strictly storage type of projects. And these projects are listed here. I will be discussing the Gorgon projects for Chevron in some detail, along with our UH involvement in a CCUS project in India. We will be also discussing quite a bit in detail. As you can see, the size of different projects, the Gorgon project is huge. It's injecting about 3.5 to 4 million tons of CO2 per year into the aquifer. And we will be briefly talking about the CCUS project that I have been involved in the last 4 years in India. Here is the Gorgon project operated by Chevron in Australia. It is one of the largest CO2 injection projects in the world. Here, the gas that's being produced from the formation contains some CO2, and then it gets separated, as you see, and finally gets injected into this formation called the Dupuy formation. And this is what we will be discussing about the CO2 storage in this field. And as I mentioned earlier, pretty significant amount of CO2 injection per year, about 3.5 to 4 million tons of CO2 per year. As shown here, there are 9 injection wells, 4 water production wells that is evacuating the water, so that when CO2 gets injected into the formation, when the pressure builds up, the water production releases that pressure, and then that water produced is getting injected into another formation. This picture shows where the CO2 is getting injected in the Dupuy formation, and water is being produced from this reservoir and getting injected into another formation. So in this formation, you are injecting CO2 and you are producing water from this. These wells are, there are observation wells here. There is a continuous downhole gauge to measure pressures and also measuring surface pressures continuously. And as you can see, there are 9 CO2 injection wells. 3D seismic is being conducted as a function of time to see how these plumes are forming and how these plumes are growing. Also, there are observation wells here that pressures are being measured in these wells continuously. So you can see a very successful example of a CO2 sequestration effort, and it is reducing a lot of greenhouse gas emission in this from this particular field. Another example that I'm going to discuss is about a natural gas injection in Agbami field, also offshore deep water in the country of Nigeria. Again, in this particular field, no gas is getting flared. All produced gas from this particular field is getting injected back into the formation. And this particular field, Agbami field, was discovered in 1998. The field came on production in 2008. And the field has been producing about 220 to 250,000 barrels of oil per day for the last 8 to 10 years, or a little bit more time right now. The field is in 4,800 feet of deep water. The reservoir depth, total depth, is at over 15,000 feet. And as you can see, the API of the oil is very, very light, 45 to 49 degrees. And there is over 2.5 billion barrels of oil in place. And recoverable oil, as you can see here, is in excess of 1 billion barrels. And some of the pressure and water depth information, they are all shown here. So this reservoir is a slanted reservoir, has a dip angle varying from 10 degrees to 30 degrees. And at the bottom of the reservoir, as you can see, there are water injection wells. And at the top, there are gas injection wells, right here as shown. So here you have a double displacement process. The gas is getting injected at the top and pushing the oil down, and water is getting injected at the bottom and pushing the oil up. And as a result of this double displacement process, you are squeezing that oil out from the reservoir and creating a very effective drive mechanism. At the same time, all the produced gas from this field is getting injected in the formation. And as you saw earlier, the oil is very light, 45 to 48 degrees API gravity. So this oil and injected gas is completely miscible, In fact, it is first contact miscibility, and as a result, you have a true miscible gas displacement process happening in this field, very successful for the over the last 10 plus years. So CO2 EOR as a CCUS technology, you can see here for a given reservoir, if you look at a schematic diagram, you have the oil production rate on the vertical axis, and on the horizontal axis, you have time. You have primary production when there is no fluids are getting injected into the formation. Then you have water flooding, where water is getting injected in the formation. And after that, a CO2 EOR, where CO2 is getting injected into the formation. This kind of process in the US in the last 50 years have been very popular. And now there are over 300,000 barrels of oil getting produced from these kind of processes. And there are over 135 projects, CO2 commercial scale projects in the US at this point in time. Many other countries are also implementing their own CO2 EOR projects, and we have a series of those kind of projects coming up in many, many areas around the world. CO2 for EOR, why and how, it is shown right here. So you have a production well, and this is an injection well. So what you do in this injection well, first you inject CO2, follow it up with water, then you inject CO2 again, then you follow it up with water. And you do many cycles of these kind of injection. And finally you drive it with the water, and you squeeze a significant amount of oil from these reservoirs. And CO2 flooding, this is the way it works. How it works is it swells the oil, CO2 becomes miscible with the oil, and it swells the oil, it removes the oil from the reservoir and gets pushed towards the production well. And by following this method, you are able to increase the oil recovery factor, going say from 35 to 45% of the original oil in place, or going from say 40% to 50% or 55% of the original oil in place. If we look at the brief history of the CO2 EOR in the US, it is shown here. 1910s to 1970s, there were CO2 field discoveries in places like Bravo Dome, McElmo Dome, Jackson Dome, and Sheep Mountain in Colorado and Wyoming. And these reservoirs got tested. Then the first notable CO2 EOR flood that happened in the Permian Basin on a commercial scale has been in the SACROC unit. Then came other projects in the Gulf Coast and in the Rockies, the Rangeley Field, and first anthropogenic CO2 EOR project in the Weyburn Field in Canada. And in 2017, the first commercial scale anthropogenic CO2 EOR project also started in Petra Nova in Texas. CO2 EOR is a proven process. You can see there are examples of many CO2 projects in the US. There are over 136 ongoing CO2 projects, and about 300,000 barrels of oil is getting produced by CO2 injection. There is about 3.5 BCF of CO2 is getting injected, and about 80% of that CO2 injection comes from the natural resources. First commercial scale CO2 project, as I talked about, has been in the SACROC unit. and in the Permian Basin. And it got started in 1972. I have been fortunate to be involved with this project for many years. And this project has performed extremely well and has become basically a great example for many companies to follow, and not only here in the US, but around the world regarding a very successful CO2 project. The performance of the CO2 flood in the SACROC field has been exceptionally good. At one time, there was a lot of debate within Chevron, who was the original operator of this field, whether CO2 really increases oil recovery from a given field. So what we did, we selected an area called the 4-pattern area, which is made up of 4 patterns of 160 acres, inverted 9-spot patterns. And in that pattern, then we flooded that area first with water and got a base decline rate as shown here. After that, we injected CO2 in that area. And in that particular area, we did not perform any infill drilling or any kind of major interventions other than which are required for the EOR flooding. And CO2 got injected at this point in time, as you can see, in June of 1981. And within a year, as you can see with the CO2 injection, this is the kind of performance that happens in this 4-pattern area that shows a significant amount of oil, and with a definite evidence that CO2 flooding does work in the field, and became a great example for many companies to follow. The same kind of performance in a pilot area was also performed in the 17-pattern areas, and from there onward, the whole industry became completely convinced that the CO2 flooding does work, as shown by this particular pilot in the SACROC field. Another project, which is operated by ExxonMobil, and also in this particular project, you can see the oil production rate as a function of time. This is the performance in this field with the water flood and 40-acre infill wells, then performance of the water flood with 20-acre infill wells, and then with 10-acre infill wells along with CO2 injections. And you can see CO2 performing extremely well along with infill production. There was a rigorous surveillance approach followed in this field, as you can see, with the help of pressure fall-off test, step rate test, profile control, artificial lift optimization, injection well rate and pressure monitoring, CO2 breakthrough monitoring in individual wells, and various other items which are shown right here. In this particular field, it was very important to maintain the operating pressure above the miscibility pressure, but at the same time, do not go above the fracturing pressure. So pressure maintenance in this reservoir played a very important role. I've been fortunate to be involved on a variety of CO2 EOR projects for the last 40 years. My first involvement was on a project in North Dakota. It was a Department of Energy joint project. DOE and Gulf Oil, the former Gulf Oil Corporation, was later on taken over by Chevron, which conducted a mini test of the CO2 miscible flooding in the Mission Canyon Formation. In the Little Light project was a Department of Energy project. And it clearly shows that the CO2 flooding does work and can move the remaining or the residual oil and increase the recovery factors from this field. I've been involved with some other projects in the Permian Basin also, northward Estes field, for example, and a variety of technical work was published from these projects that I have been involved in. This is the Little Knife field in North Dakota, where you saw I was talking about the project, and it was a successful Department of Energy Gulf Oil, now Chevron project that was conducted in the late 70s in early 80s. There are several challenges with CO2 EOR storage also. There are challenges of technical nature, there are challenges of operational nature, and there are challenges of commercial and social nature. Technical challenges include sweep efficiency improvements, well injectivity improvements, leakage and concerns along the faults, fractures in the wells, and retention and recycling of CO2. Operational challenges include corrosion, H2S handling, surveillance and monitoring, WAG, water and gas optimization, and developing and maintaining a storage development plan. And on the commercial side, these projects, as you know, are generally very capital incentives. So they are front-end loaded. CO2 pricing, at what price can we get the CO2? What is the oil price at a given point in time? What are the tax incentives that exist at a given point in time in a given country? For example, taking opportunities from the tax incentives like 45Q in the US. And most importantly, helping decarbonize and create a less emission type of situation as a result of oil and gas production. Current technology status is also shown here. Now, the industry is injecting a lot more pole volumes of CO2 than it was injected 30 and 40 years ago. There is higher injection rates. There is more emphasis on maintaining the wellbore conditions, improving the sweep efficiency, and targeting residual oil zone or transition oil zone. Also, technologies are being developed for injection of CO2 in the tight reservoirs, tight oil. And CCUS, as you are seeing the examples, implementing more and more anthropogenic CO2 capture and storage projects, including injection in aquifers. Another project that I like to talk about this morning is the US Department of Energy completed a largest carbon capture system project in Texas in 2017. It's the Petra Nova project. Petra Nova project has captured by early this year about 4 million tons of CO2 and produced over 4 million barrels of oil. It's a joint project between NRG and Japan's Nippon Oil. It's a joint venture, and the captured CO2 is used for CO2 EOR in the West Ranch field. And again, this is a great example of following a very rigorous surveillance and monitoring in this particular field, and is successful being conducted a CO2 EOR project with the captured CO2 from the flue gas stream. CCUS and EOR in conventional and unconventional resources, we at the UH, we are spending a lot of efforts in building our lab capabilities as shown right here, which will help us perform detailed studies of CO2 and gas EOR in conventional and unconventional reservoirs. And we'll be able to offer these kind of knowledge to several operators, not only in the US, but around the world. And now, what we are doing with one of our customers, the Oil India Limited, we're talking about this particular project. We have been involved with them for about 4 years. In phase 1, we performed a reservoir screening study of their 50 reservoirs and containing over 2.6 billion barrels of oil. And we see that as a result of that study, if many CO2 projects get implemented there, there will be a significant amount of CO2 captured and stored in those formations. Later on in phase 2, we started to work on the design of the CO2 EOR pilot project. And now we are working on the implementation of this project. As you can see from this picture on the right here, that CO2 capture and transportation by truck and rail, this is what the plan is. And there will be enough CO2 for a pilot test in one of the fields called 79D for Oil India Limited. A larger picture of this particular CO2 generating plant right here, and it is called the BCPL, the Brahmaputra Cracker and Polymer Limited, where CO2 will be captured right here, and the pure CO2 will get liquefied, then transported by trucks and brought to the field for injection right away. And we are going to be injecting CO2 in one of the fields right here, and we are preparing the field at this point in time for possible CO2 injection in the future. And first we'll be conducting a pilot, and depending upon the success of the pilot, we'll be expanding these projects. So this is our involvement has been with Oil India for several years. And there are many fields around here containing over 2.6 billion of barrels of oil. And many of these fields are good candidates for CO2 injection, for enhanced oil recovery, and also CO2 storage. So in summary, for the CCUS research for India, as we know, India is a very heavy importer of oil. Renewables in India are important, but fossil fuels still is the primary energy source. India's carbon dioxide emission, as you saw from one of the slides earlier, is one of the highest in the world. So anthropogenic CCUS can become a game-changer technology for India. As we know, there are many successful CO2 EOR projects that exist worldwide, especially in the US. And there are lessons learned and best practices from these projects that are going to get implemented in the projects in India. So CCUS research in India, especially for the Oil India, and other companies in India are also working on implementing CCUS project, for example, ONGC. CO2 EOR potential also exists for unconventional resources. At this time, there has been some miscible gas injection projects successfully reported by EOG, and there are quite a bit of CO2 EOR lab work conducted by various research organizations. Majors and independents are actively studying CO2 and gas EOR projects for unconventional resources. So in summary, CO2 EOR is a proven technology. There is demonstrated success over 5 decades in conventional oil fields in the US, SACROC being the first example of that, which was started in 1972. The contribution of CO2 EOR has been on 136 projects in the US, and there are more projects around the world in Saudi Arabia, in Abu Dhabi, and in many other locations in different parts of the world. Anthropogenic CCUS for EOR is growing in the US and worldwide. CO2 and natural gas EOR for unconventional resources, they provide tremendous potential to almost double their recovery factor. Additional potential for deep saline aquifers and transition oil zone and residual oil zone in Permian Basin provide great opportunities for work on those projects. And University of Houston is actively involved in transferring CCS technologies to various operators around the world. Thank you very much. I will be delighted to answer any questions that you may have.
Well, thank you, Dr. Thakur. That's a great overview. I'm going to remind everyone that while we're doing our Q&A, if you haven't already used the chat function, to please feel free to do so and ask additional questions during our Q&A period. I'd like to go back to your India presentation for just a moment. And obviously, we're in a demonstration phase. We're capturing CO2 from a facility and using truck and rail. And if my geography in India is still current in my mind, I think this is somewhere north of Calcutta. Is that correct?
Right. It's northeast of Calcutta.
Yeah.
In the state of Assam.
Okay. And in the Calcutta region, there is quite a bit of emissions coming from industrial sources in that area, so that we aren't just looking for geology that's good, but we're also marrying the geologic regime with the potential to end up capturing major volumes of CO2 emissions, if I've got that right.
Absolutely, you do. There are tremendous opportunities to retrieve CO2 from power plants, retrieve CO2 from chemical plants around the northeast region. And luckily, these fields are located not very far from those sources of CO2.
Well, it's obviously been deemed to be strategic by the government of India, by many of the industries that are participating in India. I'm just curious, how did we get involved at the University of Houston?
It is a story that we can tell as a really, really great opportunities. The Minister of Petroleum from India was visiting Houston about 4 years ago. Dr. Ramanan, myself, and several other people met with him. We developed an opportunity for them in 2016. And in October, Dr. Ramanan and myself, we went to India and signed an MOU with the government of India, with Oil India Limited, in presence of the Minister of Petroleum, Mr. Pradhan. And in 2017, another MOU was signed regarding the CCUS project by our president, Dr. Renu Khator, and the Minister of Petroleum here in Houston. And we started to work on phase 1 project in 2016. We completed that project. We moved on to phase 2 in 2017. And in 2019, late 2019, we started working on phase 3 projects. So our relationship with Oil India Limited has been very positive for the last 4 years. We are helping them in the management and research of their reservoirs, along with developing CCUS projects.
That's a great story, and it seems like we're at the very early stages of that, obviously. So much more to come, and as we get to scale up and developing those anthropogenic sources following your demonstration projects. I wonder, Dr. Thakur, if you could comment on what's often described as CO2 emissions and permanence, and the ability for us in processes like enhanced oil recovery, especially related to CCUS, that we are able to demonstrate a safe and permanent storage of that CO2. A lot of people talk about recycle and have this sort of myth that the CO2 is actually not permanently stored, but in fact it is it not?
Absolutely it is. Let me describe the answer a little bit and elaborate the answer. The SACROC project that got started in 1972, most people may not realize at that time there was no natural source of CO2 in the Permian Basin. Natural source of CO2 came to Permian Basin in 1981-82. In 1972, SACROC was collecting CO2 from various gas plants in the Permian Basin. And that CO2 got collected and transported to SACROC. So in a way that people may not realize, that was the first anthropogenic CO2 flood in the world. And SACROC CO2 injection has been going on, frankly speaking, now for 48 years. And people, you know, you talk to now, the operatorship have changed, and you can see how well different operators have managed the SACROC project, whether it was Chevron, whether it was Pennzoil, and right now Kinder Morgan, and they are all doing a great job in retaining CO2 in the reservoir. So retention of CO2 is a concern that everyone should have, but a good surveillance and monitoring program and good measurements of different parameters and running injection profiles, running pressure tests, and having a discipline of surveillance and monitoring, when they are followed rigorously, the risk is almost all gone, in my opinion.
Well, clearly the 45Q requirements for tax treatments and the like require a federally sponsored and frankly approved measuring, monitoring, and verifying program. And I think one of the things that we're excited about is some of our work now is not only aimed at enhanced oil recovery and the maximization of the ability to get the oil out of the reservoir, but now more and more with the focus on emissions, we're looking at these geologic repositories as assets for CO2 storage, are we not?
Absolutely, Chuck. And this is why I introduced a couple of examples of the geological storage. Petra Nova is one project, and the largest geological storage project in the world is the Gorgon project that injects 4 million tons of CO2 every year. And project has already started. And their goal is to store over 120 million tons of CO2. And you saw the rigorous in surveillance and monitoring and pressure measurements, running 3D seismic. That is why I brought that example. I had an opportunity to work some on that project, and I used to do the reserves review for the Gorgon project. And I had some first-hand information on that project and look at their surveillance and monitoring program. So therefore, I'm complete in agreement of having a rigorous surveillance and monitoring program, having observation wells, and making sure that CO2 is retained, not only in the reservoirs where it is depleted, where there is oil production, but also in reservoirs like the Gorgon CO2 injection projects in saline aquifers.
Mm-hmm. Well, I know we're all here in the Houston area. We're very aware that Pemex has done a considerable amount of enhanced oil recovery in the northern part of Mexico. That Pemex project for enhanced oil recovery, I believe they've actually used nitrogen, given the fact that CO2 has not been available. But clearly EOR has been a big part of their strategic plan for oil production. Obviously an oil producing country and needing those export revenues. Maybe you can comment a little bit about the Gulf of Mexico generally, in any experience you've had in terms of the potential of it for CO2 storage. Will we need to look offshore for geologic formations for this?
Answer is yes. However, we do have tremendous storage, as you pointed out, Chuck, in your introduction, in the Permian Basin. Permian Basin has the depleted oil fields that I have wealth of experience on. Permian Basin has ROZ and TOZs. Permian Basin has aquifers. So storage capacity onshore in places like Permian Basin, North Dakota, Wyoming exists in abundance. In addition to that, geological storage in Gulf of Mexico also provide great opportunities. As you saw my examples from Gorgon, you saw my examples from Agbami. Those are all offshore fields. And they are successfully conducting gas injection. In Nigeria's case, it's a natural gas injection. And in Australia's case, Gorgon's case, it is CO2 injection. So great opportunities for us for onshore, for offshore. I am very bullish on CCUS and CCS. This is a great opportunity for the US. This is a great opportunity for the world to create a situation where the greenhouse gas emission can be reduced or possibly minimized to the lowest possible level. And we, the technical people and the commercial people, have a tremendous role to play in the petroleum industry in this particular area.
Well, kind of along the lines as I reflected on the location in Assam, up northeast of Calcutta, the distances between the field and the sources and the transportation of that CO2 continues to be a major challenge. Do you see that as a big challenge in India? And then maybe do you see it as an equally difficult challenge, or maybe more so, here in Texas to the Permian?
Well, geography in the Permian Basin, as you know, the CO2 is getting transported, natural CO2 is getting transported right now from Wyoming and Colorado to the Permian Basin. The pipeline is 500 miles plus long.
Mm.
And here it is much easier compared to Assam. The northeastern part of India is very hilly, and going through with a pipeline is going to be a major challenge. And you saw the winding roads. Mm-hmm. That distance is only 55 kilometers, and we will have trucks running back and forth, transporting CO2 in the beginning for the pilot. So I would say the challenges in India, especially in the northeastern part of India, is going to be transporting the CO2. Whereas in the western part of India, the challenges are going to be a lot less. It is more like Permian Basin, flatter land, easier transportation. Whereas in northeastern part of India, in Assam, transportation is going to be challenged, but there is plenty of CO2 available. So that needs to be captured and either transported by rail or truck, or hopefully by a pipeline.
You know, there are some rules of thumb that we've all become aware of out in the Permian. Sometimes you hear that 1 ton of injected CO2 can yield something like 2 to 3 barrels of additional oil, just as a rule of thumb. Do you find that rule of thumb is consistent around the world, or does it also then become very geologically dependent on the conditions of the oil, the conditions of the geology, and thus the need for all of the testing and demonstration work?
Great question. And I really love this question because I developed some of those rules of thumbs myself 30, 40 years ago, especially coming from SACROC. And yes, if you take a ton of CO2, you'll get about 1.5 to 2.5 barrels of oil. Mm-hmm. And when you inject a ton of CO2, please remember, not all of that gets retained in the reservoir. I want to be very sincere and honest and communicate that very clearly. But majority of that, 50 to 70%, gets retained in the reservoir. And remember, it is a closed loop because the produced CO2, you don't emit it. You separate that CO2 and re-inject back in the formation. So near the end of the life of the field, you will inject that CO2 back into the formation. So then you are really not emitting any CO2. Yeah. So I think those rules of thumbs are good for the Permian Basin. I don't think those rules of thumbs are going to quite apply in different geological regions. However, we at the University of Houston are equipped to help the industry, to help different operators in developing those rules of thumbs, in developing their plans for storage. And we will be glad to do that, Chuck.
I just want to jump on one of the points you made, just for our viewing audience, just to emphasize that although the initial injection of CO2 is not completely stored, it is recycled, but in the closed loop system that you're describing, it is recycled to fundamentally extinction so that all the CO2 remains in the formation safely and permanently.
Absolutely. That is the point that you made it so clear, Chuck. Thank you.
Okay, well, just wanted to make sure there was no misunderstanding.
Absolutely.
You know, Dr. Thakur, we're near the end of our hour, and I know there's a host of other questions, but perhaps you might want to reflect on any closing comments that you'd like to make in terms of how you see the next steps in terms of what's going on in India or what's going on at the university in terms of additional capabilities and capacity to assist the industries and the marketplace.
Great. Our efforts here at the University of Houston is to help industry, help different countries to reduce the greenhouse gas emissions and achieve the goal of towards carbon neutrality. We are helping right now on CCUS projects in India. We are continuing to have dialogues with other companies in the US, around the world. And we are setting up a world-class EOR lab or CCUS lab at the University of Houston. So we will have simulation capabilities, modeling capabilities. We already have those capabilities. We are setting up the lab work. We have geoscience capabilities, strong petroleum engineering capabilities. So we will be able to help different companies in the US and around the world on CCUS and CCS projects, including the unconventional oil and ROZs and TOZs. So opportunities for CCUS and CCS are abundant. University of Houston is going to play a very important role, and our job is to serve the industry. That is our goal, and we'll continue to do that, Chuck.
Well, we certainly echo those comments from the Center of Carbon Management and Energy as the energy companies make declaration after declaration of being net zero by 2050. Certainly CCUS will be a big part of that. I want to thank you again for your remarks today and the Q&A as well. It's great having you with us, and I know we'll follow this topic up later in our webinar series in August as we talk about the Permian with Steve Melzer and looking at that geological capability that exists here in the state of Texas, which is really somewhat remarkable and unique in terms of what's available worldwide. I did also want to remind you that we do have our next webinar in July, and actually some information that's just off the press, and that is that it will be on July 21 at 10:30 in the morning Central Time, and we will conduct an hour-and-a-half webinar with two key individuals from the IRS from Washington, D.C. that will be joining us not only to make a presentation, but to be able to take your questions about the recent guidance and the impact in terms of 45Q and moving the effort forward in CCUS. It's a critical time. The National Petroleum Council study, the 18 months work has recently concluded, and we have a roadmap going forward. A big part of that roadmap is 45Q and the incentives provided to make this kind of an impact. And we certainly hope you will join us on July 21 for our IRS 45Q webinar, and certainly for August as well. Remind you again, join our website to be able to review previous presentations, webcasts that have been made. If you've missed any, catch up on the ones that you did miss. And if you haven't looked at them before, I think you'll find a wealth of information there that will create a real strong platform for you in the areas of carbon management in energy. So once again, want to thank you all for your attendance and involvement. Stay current with what we're doing through our website activities, and also take a real hard look at those two classes that we will be launching in July. for the micro-credentialing in energy development and transition, and also in our data analytics as well. So I wish you a good rest of the week and a great holiday, and we'll see you in July. Thanks.
Thank you.